Okay. We're going to go backwards from what we did last class. Last class, we went from an observation. We turned the observation into a z-score, a distance in terms of standard deviations away from the mean. And then we used the z-score to find our percent, our area, or our probability. This was last class. Okay. Turn our observation into a z-score by using our formula, z equals our observation minus our mean divided by a standard deviation. Okay. We turned our z-score into a percentage by using our normal CDF function in our calculator. Next, today, we're going to go from our percent. We're going to turn our percent into a z-score, and we're going to turn our z-score into an observation. Okay? And we will work through one step at a time. Now, let's think about how we turn percentages into z-scores. There are some that are easy that we should just know from our understanding of the empirical rule. Like if I was at the 50th percentile, where would I be on my normal curve? At 0, right? 50% is below my mean. If I was at the 84th percentile, if you remember that it was 50% below and then each of these was 34, well, we should know that this is the 84th percentile, one standard deviation away from the mean. 2.5th percentile, we should have remembered that this was an area of 0.15% and this is an area of 2.35%. So that means we'd be 2 standard deviations below the mean. Okay? So that is turning a percent into a z-score. Those are easy. From there to there, from there to there, from there to there. Okay? There is a way we're going to use it on our calculator. Finding a z-score, giving a percentile, that is not easy. We're going to introduce ourselves with this function, inverse norm. You're going to go to second DISTR, just like you would for the normal CDF, and underneath it is inverse norm. Let's all find inverse norm on our calculator. Second DISTR, inverse norm. Now, on my calculator, just go straight here. On your calculator, the screen pops up, and the screen says area, and then it's got a mu, it's got a sigma, then paste. Keep mu and sigma at 0 and 1. Okay? But the area would always be the area below a certain, the area below that you're trying to find. Okay? You would always be plugging in a decimal between 0 and 1. And it would be the percent below. Always. Percent below. So if I typed in inverse norm, 0.75. Your calculator will spew out a value. .67. What is that value? That value is the z-score that corresponds with being at the 75th percentile. This goes from percent to the z-score. Yeah.
How do you change the mean and the standard deviation when it looks like this? And there's no.
You won't change it. It'll always be 0 and 1. So if it just is inverse norm and you type in 0.75, you're good.
So it'll always be like that exact graph.
It'll always be like that.
caterpillar was.
Well, right. So the mean and the standard deviation can change given the thing, but we always want to standardize it by making the mean 0, and then standard deviations be like 1 standard deviation, 2 standard deviations away from the mean.
Okay.
Right?
Yeah.
So we always go back to this. Okay. So this is our z-score. That means if I checked and I went from 0.67 to -10 in my normal CDF, go ahead and check in normal CDF and go from -10 to 0.67, just like we did kind of all day today, you should get 75%. Check. Go from -10 to 0.67, you should see 75%. Okay? Just about 75%. So this inverse norm goes backwards. It goes from the percentage. Here is the percentage that we plug in. And it turns into a z-score. All right? So what would be the 50th percentile? You can type in inverse norm of 0.5. Try that. What should we get? 0. That makes sense. 50% of my data is below the mean. The mean is 0 standard deviations away from the mean. Okay? So if I have 50% here, the z given by inverse norm is 0. What about the lower quartile? That would be the 25th percentile. Find that out. So if I had area that was 25%, maybe like this, what is the corresponding z-score that goes with that area? -0.67. Did you guys get that? Okay, well that means I actually got to fill in a little bit more to get here, and at -0.67 for a z-score, 25% would be below that. Okay. Next one, let's think about, what about the 95th percentile? So that means if I had an area that covered 95%, what would that correspond with a z-score of? If I pull in and I get all the way up to 95%, maybe I'm around there, maybe I'm further, what do I need to get to? 1.64. So really, I was kind of close with my guesstimate. Okay, now here's the key. This is always percent below for inverse norm. Inverse norm always does your percent below. What happens if I asked you what z-score has 30% of the data above it? Excellent. Mr. Englander, you said 70 below. So what you did was change the question. Since you know inverse norm always deals with the percent below, if we're talking about 30% of the data above it, change the question. Take 100% and subtract your percent below, percent above, and you'll get your percent below. Okay, write this down. This is important. You take 100%, you subtract your percent above, you'll get your percent below. So Mr. Englander said, okay, 30% above is the same as 70% below. And we figure out that we get a z-score of 0.524. Now, it's very important you get this decimal, 0.524, and we got this decimal, 0.674. These are not percentages. Those are z-scores. Those are distances away from the mean in terms of standard deviation, okay? Distances in terms of standard deviation. So if I had 0.524, it turns out that would be 70%. So I was a little bit off in my picture. I should have been right here, and this would be 70%. Okay? So we just figured out how to go from percent to a z-value. We use inverse norm. Good. That's step one of going backwards. Step two of going backwards is we're going to have to go from a z-value to an observation. Let's go over step two. After that, I want you to do these, though. These are practice. So let's practice this step one. Go from a percent to a z-value. Find the z-score or the standard deviation distance away from the mean given the percentage. So if you're in the 90th percentile, what's your z-value? If you're in the 20th percentile, what's your z-value? If 70% of your data is above this value, where are you? If 5% of your data is above the value, if 52% is above your value, find your z-score. Get all 5 answers. Check your answers with a neighbor. I want to see all 5 either on your calculator or written down. I will do them as well. Okay, check your answers with a neighbor. Go. All 5 of them you need to get and you need to check. Looks good. Awesome. Just like you did it. All the ones, if you did inverse norm of 70, then inverse norm of 0.05, then inverse norm of 0.52, you done them all wrong. Inverse norm is all percent below, okay? So if we're talking about percent above, we have to change the question into a percent below. Good. Here are our answers. Up on the screen, we should get 1.28, negative 0.84, 0.52, 1.64, and negative 0.05. Okay? This is just inverse norm of 0.9, inverse norm of 0.2. This would be inverse norm of 0.3, This would be inverse norm of 0.95. This would be inverse norm of 0.48. Whenever you're talking about percent above, you need to change the question into percent below. You got negative 0.52? Oh, I just didn't type in a negative. That's not right. Okay, good. Sorry. 95. Change that into percent, 0.95. Boom. Inverse norm, 0.95. Okay. All right. So that's step one, changing a percent into a z. Step two, finding your observation given a z-score. We got to go from a z to an observation. Remember this formula. A z is equal to an observation minus the mean divided by my standard deviation. If you don't have that down, write it down again. This will be the formula that you use, or we're actually going to develop our own formula. You can algebraically solve for an observation. Watch, if you're given a z-score, a mean, and a standard deviation. We have caterpillar's lengths are a mean of 3 inches and standard deviation of 0.5. What would be the length of a caterpillar be if he was 2.4 standard deviations greater than the mean? Watch how I can do this algebraically. Using this, I can say, okay, 2.4 is my z-score. I want to know what my observation is. I can just replace it with an x. I can subtract my mean of 3, and I divide by my standard deviation, which was 0.5. How do I solve for x? I'd multiply by 0.5 on both sides. I'd get 1.2 is equal to x minus 3, and then I'd add 3. I'd get 4.2 is my observation. Well, that's fine. However, if you want to just use a formula every single time, watch how we can just manipulate this formula up here. If I have z equals O minus m divided by STD, I can multiply both sides by the standard deviation and then add my mean, and I'll get my observation. So we have a new formula. If we want to find an observation, given a z-score, a standard deviation, and a mean, just take your z-score, multiply by your standard deviation, add your mean, and all of a sudden you get your observation. Same as just using this formula. So if a caterpillar was 2.4 standard deviations greater than the mean, I'm plugging in a positive 2.4 for z, multiply by the standard deviation, add the mean. Algebraically, it looks like this. Manipulating the formula to look like this, we get 4.2. Okay? Now, your turn. Hospital ER wait times are normally distributed with a mean of 127 minutes and a standard deviation of, let's say, it's 37 minutes, because 57 is too long. Okay, this is practice for Z to observation. How long did you wait if you waited 1.2 standard deviations more than the mean? Go. Check your answer with a neighbor. What do you mean you don't know? I just showed you.
I know.
There's two ways to do it, Ms. Jameson. Either solve this algebraically or use this formula. Take your z, multiply by your standard deviation, add your mean. You get your observation. Z is your standard deviations away from the mean, right? That's what Z stands for. Yep. Plus 127. Okay, good.
We don't have halftime safety, or is this the end of the day?
Yeah, we do. We have cutoff. 171.4. Did we get 171.4? 171.4. Excellent. 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 Okay? Take your z-score, multiply by your standard deviation, subtract, add your mean. Now, you might forget this. If you forget this, you can always go back to this and solve it algebraically, or just develop the formula yourself. Okay? It's something that I don't want you to remember and then forget forever. You can always just remember one formula and use it every time. All right, how long did you wait if you waited 2.1 standard deviations less than the mean? Go, figure it out. That works. That works. Good. Good. Excellent. Make sure we understand what 2.1 standard deviations less than the mean is. We should get 49.3. Are we good? 49. What does it mean to be 2.1 standard deviations less than the mean? What's our z-score? Negative. Negative 2.1 is our z. So we should have negative 2.1 equals, I'll just show you the other way to do it, 0 minus the mean divided by the standard deviation, multiply by 37, add 127. Okay, we get our observation is 49.3. Or you can, of course, use the z times the standard deviation plus the mean. All right, we did both steps. Now we're going to put it all together, do them all at the same time. We're going to go from our percent to our z, then our z to our observation. Reminder, a z-score is not a percent. If you go and you plug in inverse norm of, say, 0.65, and you get a value, what's inverse norm of 0.65? 0.385. That is not a percentage. This is a z-score. What's a z-score? It's a distance in terms of standard deviations away from the mean. Okay, so don't forget that. Here we go. You can sketch your normal curve too. That might be step one, just to show you exactly where your areas be, but sometimes it's harder to see exactly and you might confuse yourself. So all it is changing your percent into a z and then change your z into an observation. Here's your first example, SAT example. We got mean SAT score for the University of Texas is 1815. The standard deviation is 252. What did a student at the University of Texas get on the SAT if his or her score was at the 90th percentile? Here we go. Step one. We will change our percent into our z. Do that. What do we get? 1.28. Now, here's the key. In your calculator, it's going to be 1.28 with the other decimals behind it. Hold on to those decimals. So inverse norm of 0.9. Come down. Hold on to those, okay? Step 2 is you're going to change your z into your observation. Step 1, we use inverse norm. Step 2, we're going to go from z to our observation using your z value equals your observation minus your mean over your standard deviation, or your new formula. You're going to use your z times your standard deviation plus your mean. So watch what I do using my calculator. I already have my z value, 1.28, okay? You have to be 1.28 standard deviations greater than the mean to be in the 90th percentile. I will then take that value and multiply it by the standard deviation of 252. Just press multiply, you get your answer, the previous answer, times 252. I know most of you know this, I'm just going to make sure. That gives you that value. You then add the mean and you get 2,137.95. Okay, this is 1.28 times 252 plus 1850. And we just did all the steps. We just answered this problem. We went from percent to z, then z to our observation. What score, this is your turn, this is a challenge, here we go. What score did a student get if 30% of students did better than them? Go. Good. Good. That looks good. Let me see your inverse norm. Perfect. Excellent. Now just take that value and instead of simplifying it like that, just immediately multiply. Okay, then add. And it'll just be a little bit more exact. Start with your percent, change it to a z. Once you get your z, change it to your observation. You're going to use inverse norm to change it to a z. Once you change it to a z, you're going to change it to your observation. Where's your z? Okay, good. Now, 30% did better than them.
So
Are you at negative or are you at positive?
Negative. No, positive.
Right, 30% is better, 70%, so it should be positive 0.2. Good, we should get 1947. 1947, you get that? Good. Now just don't round this. You know, just like I showed you, you just immediately press times and it'll save that entire decimal. Okay, let's,
I just cleared it.
well, let's see, because I can press second entry. Second entry. Okay, well, that works. But I want to see all the work to get that. Excellent. Did we get it? Good. Good. All right. Fine. Great. On my calculator, it should just be inverse norm. Now, if you don't have it in your calculator, do it now. You're going to do inverse norm of 0.7. If you think about your curve, 30% did better. That means 70% is below. We know inverse norm is all about percentage below, so we have to change that question to what score did a student get if 70% of students did worse than them? And now we can use inverse norm. We do inverse norm, we get a decimal that is like around 0.52. Now the best thing for you to do is to leave that decimal in there. So second dister, 0.7, inverse norm 0.7. Leave that in there, okay? Immediately, you know you're going to take that value and you're going to multiply it by your standard deviation, 252. So I have it, just press multiply and it goes answer times, and then I'll add my mean, and I get 1947, okay? So this is 0.52 around. Take that number, times it by your standard deviation, add your mean, you get your value. Okay, next problem. Heights example. We have dudes have a mean height of 70.1 and a standard deviation of 2.7. Females have a mean height of 64.8 and a standard deviation of 2.5 inches. Here is your question. How tall does a woman have to be at the 35th percentile? Go. '35th percentile is automatically percent below. $64.8. Sorry, you're right. I kind of deleted that. Should see it on your calculator. What is the height? Kind of erased. There we go. Let's see it. What is the height? '35th percentile. What's that area? Okay. That's your z-score. Take that and turn it into an observation by multiplying it by the standard deviation and adding your mean. Standard deviation is 2.5. That's the standard deviation for men. So go back, go up, 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 enter. Multiply that by 2.5, add the female mean, and I should get 63.83. Questions?
Teacher, this is part of this interruption real quick. We just want to make sure that for third period, we have these announcements made.
Why don't you wait till cat time?
For baseball, please go to Coach Mears' room, C207. Third period baseball, go to Coach Mears, C207. And then JV girls soccer will meet in a study hall in B204. B204 is JV girls soccer. And then ag, you will also do exactly what we did a while ago. We will meet at the front door and go out to the ag bus, which will be at the bottom of the stairs in the front. Students also reminded that we have our Halloween contest in the PAC during all lunches. So if you're dressed, you may leave the cafeterias and go to the PAC for the judging of your costumes.
Thank you.
And then we have a boys soccer going to J205, third period, J205, boys soccer. Thank you, and everybody stay dry.
Okay. Next question. In order to be in the Tall Club of America, you must be in the top 10% height range. What is the cutoff for males and what is the cutoff for females? Go. Top 10%. That'd be this right here, right? What are you plugging in inverse norm? Nope. Not 0.1. You know you're putting in 0.9 because it's 90% below you. 1.28. That's going to be for both the males and the females. Multiply by your standard deviation. Now it'd be positive, right? If you plug in inverse norm 0.1, you'd get negative 1.28. The top 10% is up here. That means 90% is below you. So you need to go inverse norm of 0.9. Remember, change the question from percent above to percent below. Z times the standard deviation plus the mean. Z times the standard deviation plus the mean. And what did I get for males? 73.56. And what did I get for females? 68. How do we feel? Pretty good? All right. Let's start our homework. Our homework is a worksheet. I advise you to do it before you leave. We have questions that go from a percentile to an observation, last class. We'll have questions that go from an observation and get to a percentile. Wait. No. Percentile to an observation, that's this class. From the observation to the percentile, that's last class. You'll have to be able to go both ways. Remember, if you have an observation, you'll turn it into a z-score and then use normal CDF to find your percentage. If you have a percentage, you'll turn that into a z-score using inverse norm, and then you will change that z-score into an observation using our manipulated formula. Multiply by your standard deviation, add your mean.
And what is our review day?
The review day is next Thursday. The report is due next Thursday. So part of your homework is also to start working on your project. Remember, the most important thing about your project is this rubric. Every single item needs to be covered. If you have any questions about any of these items that are on the rubric, you ask me, and I will also help you make sure they're on your project. If you don't ask for help, I can't give you help.